Welcome to exercise 6, which is simulation of deterministic finite automata. What are we going to do in this exercise? Let us try to take a string and check whether the string is a part of the language. How do I represent it? Any regular language can be represented by three ways. First one is based on the regular expression, second one is using regular grammar, and third one is by modeling and finite automata. To our understanding, finite automata can be deterministic or non-deterministic. What are we going to concentrate on this exercise is an deterministic finite automata which doesn't have any empty transition, as well as the input state symbol pair will have at most one output, or it will not have any other output. And to recall, a deterministic finite automata is a mathematic model which consists of a set of states which are represented as q, set of input symbols which are taken from the alphabet sigma, and the transitions would be q cross sigma, which produces a transition state as the output. And among the set of states q, one state is considered as a final state, and one or more states can be considered as one state is considered as an initial state, and one or more states can be considered as a final state. To recall, you have an DFA for A or B, the whole closure AB. We have a single initial state and then single final state. Now, how are we going to simulate and deterministic finite automata? The next slide, we'll be looking at the algorithm for it. Having said the finite automata is one which represents a string in the language and checks whether the string is a part of the language. Let's take the initial state first. Assign it. Let's take the initial state first and assign it to an variable s. This variable s indicates the state at a particular point of time t. Now, what am I supposed to do? We have to have the input symbol state symbol pair in order to find the output state. And therefore, we have two inputs which are required to make a decision. The first input is the state, which I have taken it and assigned it to yes. When I read the next character, take it and assign it to C. How many times am I going to read it? I'll read it till I reach the end of the string. Okay, and then you have a transition. You check whether you have an input pair on S comma C, which leads to an output state, which is now stored in the current S. And you read the next character. This moves on until I read the next string, end of the string. Now, at the end, when I reach yes, check if S is an F in the final state. I am going to check yes is a part of the final state subset because it is a set of states which is part of Q. If so, you return yes. If not, you return no. Now, what are the inputs are we going to take? Number one, we require a transition table. This transition table can be obtained based on the input symbols and based on the number of states. And therefore, we'll try to understand the inputs what are required. Number one, I'll talk about the number of states as the first input. For example, based on this previous input, let me take the number of states to be 4. And then what am I supposed to do? I am supposed to take these 4 states as input. So I have an state array, an array Q, wherein I'll move from 0 to 3 and enter all these 4 states as input. Okay. And then we are supposed to talk about the input symbol. So now the valid input symbols should also be a part of it. And therefore, the valid input symbols, again, the number of symbols has to be taken, where I take it as 2. And those symbols would be A, comma B. Now, the third input. Third input is to be the start state. You should know which is the start state. In this example, the start state is A. A has to be part of the number of given input states. So the start state here is A. And then you have to talk about the number of final states. In this case, it is 1. If it is 2, put it onto a final state array. So I'll take it as 1 and the entry is D. Right? So how have I taken it? I have asked for the number of states as 4. This is an user input. And then these states will be put into an array. For example, let us put it into an array Q where I have given A, B, C, and D as input. And then the second input is the number of input symbols, which is 2, which can also be put onto an array. Maybe we'll take it as yes. It depends on how you decide. Or if yes confuses us, we'll take it as I for indicating it is an input symbol. And this input symbol would be A, comma B. Now, the third input is the start state. When I give the start state as input, check whether this A is a part of these 4 states. If not, you have to ask for a re-entry. Fine. And then the fourth input is the number of final states. I have given as a final states to be 1. If it is 2, I can, for example, if it is 2, I can always have an F array which gives me the input, which takes in the final states again as input. For example, it is C and D. Check if C and D is a part of the state queue. Now, in this case, we'll take it as 1. Even if it is an array, we'll take the final state to be C. Having said this, then I'll go in for a two-dimensional array wherein I'll take the input of this part alone, because if I take the transition table as input, let me take it as an dtran array, which is of size the number of states. Okay, let me take it as ns and the number of input symbols ni. You can use the variables as you want. So ns and ni. Now you know ns of 0 will be a based on q of 0. So ns of 0, ns of ni will give you this input. When I is 0, I is 1, and then move forward. So you have an for loop, get the arrays as input or do the way you want to. So this transition table is a two-dimensional array, which is your fifth input. And the last input is the input string. Once this is given, where do I start? I start from the first part. Okay. So I'll take this the index value as 0 for our easy simulation. I'll take it as 0 and then I'll read this character, map it with A or B. If it is mapped with A, your I value is 0, Ni value is, you have an index variable, right? The index variable I goes along with Ns, and then the index variable J goes along with Ni. So how do I start? I start with I to be 0 and J to be either A or B based on the first character. So you map the first character with the alphabet, take the index value, and then you start with 0, comma 0. It need not be the case. The first character can always be B where it is 0, comma 1. So now what happens? When I take 0, comma 0, You know what the output is. It is B. Fine. Now B has to map with your Q array to find the I value. So B is mapped. So what we'll do, we'll go ahead with 1, and then the next character A is mapped. So it goes ahead with 0, and then you 1 comma 0 is B again. So B is mapped. It goes ahead with 1, and then the next character is B. So it goes ahead with 1 comma 1. Fine. And now what is 1 comma 1? It is C. So now what happens? Your index variable becomes 2. And then what about B? B moves on to D. So it is 1 2 comma 1, which leads to an output state which is 3. Now, what about the character? You will read an end of file. For our easy understanding, let hash or dollar symbol be your end of the string. It is not EOS as we saw in the algorithm. We'll have it as hash or end of string as dollar. And when you read that, take this value, map it with what you have. You get D as the output. Take D and check if it is a part of the final state. You have the output. If it is a part of the final state, you are going to print yes, else you are going to print no. So this is what is expected in simulation of an deterministic finite automata. We are not going to construct it. Rather, we'll take DFA as input. To take DFA as input, I'll reiterate: number one, you need the number of states along with the states. Number two, the number of input symbols along with the what are the input symbols. A symbols can be A comma B, 0 comma 1, whatever it is. Then number three, the start state. Number four, the final state. Start state and the final states have to be validated along with the state which you have given as input, and then a two-dimensional array of an deterministic transition table. And then the sixth one is the string which we take as input for recognizing to check whether it is a part of the language. Fine. Hope you have understood it. And with this, we'll wind up exercise 6. If you have any clarifications, you can post it back to me. Thank you.